All right, good afternoon. Everybody's back from lunch. Oh, maybe not everybody. This is Incident Response in the Cloud. I'm Don Bailey. I'm a principal geek with the AWS security team. My day job is protecting customers and AWS itself.
And I'm Greg Roth. I'm with the AWS Identity and Access Management team.
So we'll be talking about incident response in the cloud. If we ask ourselves why we should care about this, first of all, security doesn't stop at compliance. You may be checking off all the boxes, but there's probably something that might happen within your environment, and you'll want to go and look at that. And that might not be covered by a compliance checklist. However, some people do have a compliance requirement to actually implement an incident response plan, so there's a good reason to care about that. The knowledge that you gain here today will help you react to any sort of incidents within an AWS environment and provide you with the agility to continue to provide the availability of your service to a customer. Stuff happens, and it's pretty good to prep for those types of things, and I hear that prepping is fashionable. So what we'll be covering today will be incident response in general, as well as IR versus the cloud. We'll talk about incident response with regards to AWS best practices. We'll talk about some prerequisite knowledge that you should have, and certainly some things that you should be paying attention to, turning on and leveraging. We'll also go through an incident management lifecycle specific to an AWS concern. We'll look at some indicators that might lead you towards an incident and actually having to perform incident response. We'll go over a couple example incidents, and we'll talk about IR workflows associated with those. We'll give some tips, we'll mention some tools, and we'll also point you to some other IR resources. So when we're talking about incident response, we usually have a number of different goals that we're trying to achieve in the process of responding to an incident. We want to establish control, then determine what impact that particular incident has. We want to recover, get back to a known good state. We want to investigate the root cause of that, and ideally we want to learn from that and go forward. You want to think about first aid or firefighting or crime scene investigation, but we're going to gear that towards Amazon Web Services today. So when folks are thinking about incident response, but thinking about it in the context of Amazon Web Services, Greg, what should they be thinking about?
So be aware that, well, many of the things that you'll do when you're responding to an incident with, say, a single server in an on-prem environment are similar and directly translate. There are some additional considerations that you're going to want to think about when you're responding to an event in a cloud environment. And there are some new tools that you have to work with. A lot of the configuration that defines the topology of your application is different, and you have the advantage of it being programmatically accessible, easy to query, easy to script. So there are many things that you can do in a cloud environment that are actually harder to do elsewhere.
And you also want to understand that incident response within AWS is not just about your EC2 instances, not just about your Amazon S3 objects. Far from it, there's a few other things that you're going to have to pay attention to, right?
Yep, so in addition to the EC2 instances and the S3 objects that you might think about right at the beginning, pay attention to the rest of your configuration, any beanstalk applications you might be running, any identities that are used to access resources in your environment, as well as the overall configuration, the policies that span multiple services. And we're really focusing more on the configuration that spans multiple services, although we will talk to you a bit more about some things that are unique about responding to EC2 instances as well.
And just like in the previous talk with intrusion detection in the cloud, we mentioned a lot of prerequisite knowledge that we expect our customers to have when they're going to be investigating an incident specific to their AWS environment. What are those?
So to condense that down to about 2 minutes, we hope you're all already using AWS Identity and Access Management. In particular, if you were to have a credential exposure, you will be a lot happier if that credential has some amount of least privilege applied to it. And least privilege is hard, we know that. But getting at least a baseline amount of least privilege and ensuring that things that do not need the ability to change your security configuration, your policies, don't have them will save you a lot of headaches and make recovery that much easier. You'll want to think about roles for EC2 and consider using it when you're running your application from EC2 instances. That will give you the advantage of individually auditable credentials that are rotated for you with no effort on your part multiple times a day. Many customers struggle to rotate credentials annually. Roles for EC2 does it multiple times a day. Multi-factor authentication is something that we always recommend. Passwords are not the greatest, and they are often mishandled. Multi-factor authentication can completely exclude that class of problem. When you're responding to an incident, you're going to want logs, and you can't read the logs that you don't have. Turn on AWS CloudTrail. It's one slider in the console, enter a bucket name, and you're done. Can't emphasize enough the importance of having logs rather than guessing what happened. Similar story with S3 versioning. So you can't restore the backups that you don't have. S3 has a feature called versioning where you can tell it that it should retain objects that were deleted, and then deletion becomes just removing a pointer. You can access old versions by using the describe version APIs. And if you go that route, you can even opt to require MFA to remove a version. You can also protect yourself from inadvertent deletion, inadvertent overwrite, and along with the least privilege comments earlier, you want to not actually give anyone the ability to call the delete version API. Bucket logging. Again, you can't review the logs that you didn't ask us to keep. Turn on bucket logging if you have data in S3 that you care about.
Yeah, it's important to understand that this talk is not about announcing a new time machine that we've built to help you with incident response. Instead, we'd like you to use the time machine we already built.
So what else do I need?
Well, we assume that you also have people, tools, and a plan associated with incident response. And it's probably going to be a good idea to have those things in place before you actually incur an incident.
I don't want to just develop it on the fly?
Maybe not. But let's talk about an incident management lifecycle specific to AWS. So you may already have an incident response plan, and you're trying to figure out, how do I talk to AWS about my concerns and responding to incidents within my AWS infrastructure? Well, just within your existing IR plan, you'll probably want to categorize your incident, whether it's a performance-related issue, whether it's a security concern, whether it's a traffic-related concern. And you want to categorize that first and then determine the impact and determine whether or not it's something that AWS support is required to help you with. If it's something that you cannot handle yourself, you should absolutely engage AWS support. We're your one-stop shop for helping you through any number of different concerns, security-related or otherwise. Open up a support case. AWS support then engages internally subject matter experts on your particular concern to help you resolve that particular issue, recover and get back to a known good state, resolve that, and then learn from that going forward. If there are things that we need to do better to help you, we'll do that. And if there are things that you'll need to do better, you'll get to incorporate that as well. So what are some things that we're going to look for that may lead us towards having to go and investigate something as an incident?
So there was a whole talk about 2 hours ago about detecting incidents. That is not this talk. However, it's worth reiterating that there are a number of important notifications that AWS may send you. For example, there are scenarios where we may notice that a credential associated with your account is posted more publicly than you might want. And those notifications don't help you if you spam filter them. So please ensure that we have updated security contact information, which you can find in your account settings, and actually read those notifications. Similarly, you may be notified if we see one of your EC2 instances behaving in ways that you might not want it to. And then, of course, if you were to notice a credential or an identity in your account that you don't have a reason to be there, if you were to notice the use of resources that wasn't expected, or if you're actually reading your logs and you see things in the logs that you didn't expect, that's an indicator that you might want to dig deeper. Check out the latest version of SEC402, which should be on YouTube, and if not, there's last year's version for a whole lot more about detecting incidents.
And so,
let's walk through one of the scenarios that might happen. You might discover that your AWS credentials, your access key and secret, are posted publicly, say, to a source repository. Maybe it went to some exciting destinations without you, and all you got were some EC2 instances. What do you do then?
Well, first of all, I'm going to have a stern talking to the intern and the project that he decided he was going to post on GitHub that had my AWS credentials in it. And after we get done with that, I'm going to go talk to that source code repository, and I'm going to delete that file. And then I'm going to talk to every search engine on the planet and ask them to delete their cache so that that's not on the internet anymore. And then we're done, right?
So that's actually a mistake that we've seen multiple times. You do not remove sensitive information from the internet. You do not try to erase credentials that were exposed. You rotate them, and we'll walk through how you do that safely. But before you get started in rotating your credentials, take a step back for a moment and think about what you're doing so that you avoid making the problem worse. So the first thing that you're going to want to do is figure out what level of access was associated with the credential that you just discovered. You're also going to want to think about the trade-offs between the availability of the application that those credentials are part of, and trade that off against the confidentiality and integrity requirements of data that those credentials have access to read or modify. And this is where having a plan and having thought about this in advance really helps you. It's much better not to be making those hard decisions at 3 in the morning. And then once you have a handle on that, ideally from the plan that you already wrote, you're going to want to take some immediate steps to stop the bleeding and limit immediate further damage. And once you have immediate mitigations in place, you'll clean up the mess. So let's talk about how you actually determine the level of access. There's a spectrum on AWS credentials. The worst case is root credentials, which are the credentials associated with your account. Trusted Advisor actually tells you if you have root credentials, that's a finding. You're not supposed to have them. We recommend eliminating them. IAM user credentials, you want to look at the policy on the credential to tell you what level of access it has. And when you're looking at that, you're going to want to look at that from the mindset of, it really doesn't like that slide. Configuration, integrity, and confidentiality, so what resources those credentials have access to. And you'll want to think about how important is the data, how important is it that the application remain up, and are there parts of the application that we can edit? And so the slide that we just skipped again was a link to the SEC402 security config script that actually will retrieve a full list of credentials in your account. You can use that to help you figure out where that credential that may have been exposed was attached. Oh, this time it's useful. Okay, so access policy language. You're looking at the policy on the user whose credential was just exposed. And again, we're hoping this is a user and not a root account. There's a whole talk on the AWS access policy language. The really short summary is that the way policy evaluation in AWS works is there are a bunch of statements. Each policy is one or more statements. And access to an AWS API is allowed if there is at least one statement that matches the request that says effect allow, and there are exactly 0 statements that say effect deny. So denies win if they are present, and you need at least one allow. Each statement actually is made up of 5 components. There's the principal, which is either the user that the policy is attached to, or in the case of a resource policy, like an S3 bucket policy, will be explicitly present in the policy. An action, which might be something like S3 get object. It's a specific AWS API. Action of star is bad, it means anything. Action of S3 : star is less bad, it means anything in S3. Action of IAM : star is really bad, it means can change all the policies anyway. There's also a resource field that can say this bucket, that bucket. Often the resource field will be star, that's not unusual. Conditions are used to further scope down policy, say for example that it only applies to calls made over SSL or applies only from a particular network range, and then the effect is either allow or deny, which tells us what to do when the statement matches.
Our policy language is very, very powerful, but we promise you that it's less complex and more deterministic than palm reading.
It's deterministic, it's just challenging sometimes. So when you're looking at these policies, you're going to be wanting to pay a lot of attention to the effect of the credential that may have been exposed on the integrity of your configuration. Write access within the identity and access management product is something that you're definitely going to want to pay close attention to. That's things like user creation or put policy, which can change other policies in the system. Changes to EC2 security groups, changes to EC2 keys, changes to policy and other services like S3 put bucket policy. These are things that will cause you to have to look more carefully at the configuration if you were to have these abilities on a credential that was exposed. So now that we have some understanding of the level of access that was on this credential, we move on to coming up with a plan. And in some order, you will want to revoke any privileged access. This is where your application might ordinarily have some advanced functionality or some administrative features that you might be able to safely turn off while you're responding to the rest of the incident. And you may only have part of the application where the availability is critical. If that's the case, turn off everything you can safely turn off. You may want to revoke outstanding temporary security credentials, potentially invalidate the credentials that were exposed immediately, potentially wait a bit longer. Let's talk about revoking privileged access. So you've determined that you've got a user whose credential was exposed. You've looked through the policies on the user. Let's say you find a number of them. And to do that, you're going to go into the Identity and Access Management console. You'll click on the users on the left. You'll click on the actual user, and there's a policy section. You'll see a list of the policies that are on the user and on the groups. Sometimes people will find that they don't want to edit the policies that were in use on the running system, either to preserve them as evidence for later or to make their changes more reversible in case they break something at 3 in the morning. And so the safest thing you can do at this point is add an additional policy, and you just click Add Policy, you'll get the policy generator, and you might either attach a policy that blocks all access to IAM, or you might set a policy that blocks all access except to S3, like the policy that we have on screen. You'll see here we're using the not action version of action to specifically deny everything other than S3.
And we generally don't recommend that people use this as an approach to generating policies for their production environment. But this is in response to?
This is something that you might apply in the middle of an incident. It's hard to manage policies with effect deny. They tend to cause problems for you. You can't override them anywhere else. They are the exception. There is no undeny the access that was denied over here. And so don't typically apply broad deny statements, but for short periods of time when you're responding to a potentially exposed credential, it can be useful.
It isn't putting the genie back in the bottle, but it's telling the genie to behave a bit.
So invalidating credentials, you actually have two options. You can either disable a credential or you can delete it. The difference is reversibility. If you disable a credential, you can go in and re-enable it. So for example, if you disabled a credential that you then learned was on a production server that you have no access to, and the guy who knows the password for that server is on a plane, you can re-enable it and make the trade-offs of, do you want it on, do you want it off, you know it's out there, what's the risk? Deletion is final. So once you're sure that nothing was using the credential, you do actually want to delete it so that someone doesn't inadvertently turn back on a credential that was known to be exposed. You'll want to provision new credentials for authorized usage. You'll want to deploy the new credentials. And the order that you take the above actions in depends on whether you're willing to take some downtime or whether you're less worried about potential exposure of the data in this scenario and you want to proceed more carefully. One other thing that's worth noting is when you're provisioning new credentials, it's helpful to actually create a whole new identity. It helps you separate access that happened before the exposure, during the exposure, and after the exposure, in that your audit logs will tell you that it's the new identity. After you've done all this and you're back in the situation where you're starting to regain control of the incident, you're going to want to do a deeper dive, start to figure out what's wrong, look at what changed. Best case scenario, CloudTrail logs are a wonderful resource here. The configuration reports, either from the tools that we talked about in SEC402 or the new AWS config service, look at the diffs there. Less ideally, run a report now, look at what changed when. Many AWS APIs report a change timestamp. That can give you some pointers on when changes were made, and you can build a timeline with respect to when the credential was exposed and what changed afterwards. You'll also then want to lock any credentials that might have become exposed. This is a sample of a CloudTrail log with a bunch of things pulled out to make it fit on a slide. In red, you'll see an access key ID. So you might look through your CloudTrail logs for any actions that happened under the access key ID that the secret for which was publicly exposed. This particular entry was a user creation. And let's talk about where access might persist. So new users might be created, new credentials might be put on existing users. For example, if you have a programmatic use-only identity that has access keys deployed, make sure that it doesn't suddenly have a login profile, which is a username and password. Your web servers are unlikely to be logging into the management console. And again, X509 certificates, there are multiple credential types. Make sure that every credential on every identity in the account was actually supposed to be there. Roles are a great resource for cross-account access. It also means that they're a great way to set up cross-account access. So you'll want to look at the trust policies on roles and ensure that they're not configured to allow access to other accounts. And you'll want to look at resource policies for resources that you're worried about. You may want to look for temporary credentials and turn them off, and you may want to look at things like EC2 instances that are configured for roles for EC2, where we are delivering credentials to the EC2 instance. Make sure those are instances that you expect to be running and not ones that someone else started.
So what if there are temporary credentials that have been generated and they might be out there?
So once you turn off an exposed credential, it's possible that there are still outstanding temporary credentials. The STS get session token and the get federation token APIs provide temporary security credentials that are good for up to 36 hours. Assume role provides credentials that are good for up to 1 hour. You should look at the CloudTrail logs for any signs of these having been created. If you followed our earlier advice about creating a completely new identity, then this is less of an issue. Just drop a policy that blocks all access from the old identity and you're done. If you're not in a situation where you can do that, revocation is worth paying attention to. This is an example of a CloudTrail log showing temporary security credentials. And you can see here the access key in red up at the top is the one that I was worried about. The one at the bottom is the one that was actually created. And you can see this is a get session token call. If you're not in a position to completely block access to the identity that had a credential exposure, you can put a policy like this one on it that blocks all access taken using temporary credentials that were issued before a certain point in time. In this case, one's before, I guess that's tomorrow. And you'll be a little bit careful when applying this policy to roles. If roles for EC2 has not yet delivered new credentials, this will block all access from an instance until it picks up new credentials. After you think you've got the situation under control, you think you've completely regained control of the account, you'll want to keep watching your logs. And ideally, there are no signs of continuing access. If there are, then repeat the process, see what credentials exposed, go through the steps again. Eventually, you should be in a situation where you're no longer seeing unauthorized access.
So let's talk a little bit about EC2 instances, those that might be exhibiting a behavior that is undesired. The first thing that we're going to do with EC2 instances that might show up or again be behaving in a manner that we're not too crazy about is preserving configuration data. So we want to preserve information about the instance, such as its Amazon machine image ID, the security groups associated with it, all the names that have been used for that, when those things were created, anything that's configuration information about that particular instance. So you can use the AWS API to dump this information. You can also take screenshots by going into the AWS Management Console. You'll want to take notes, make sure that you document all along the way. Now the next thing that we'll do is isolate the instance. We'll do that by changing the running instance's security group to something that's much more restrictive than its existing security group. And then we'll inventory associated credentials with that EC2 instance. If we can constrain or disable those credentials, we will, and we'll do that in the manner that we previously discussed with regards to identity access management credentials. Now moving on, we want to determine the actual impact of this EC2 instance and what it's been doing, and determine what it might actually have been connecting to, or what it may be, what it may have transitive trust to. And so we'll revisit all the associated credentials, again, evaluating the scope to determine if those credentials have access to other services, but we're not just talking about AWS credentials at this point. Anything that's on the actual instance, whether it's in configurations, usernames, passwords, and it's talking to other services, we'll want to make sure that we're looking for those, inventorying those. Again, make sure that you're preserving data, all of this information along the way. Now, security group inheritance is something to pay attention to here as well. You can provision access to a security group by calling out another security group and saying this security group B is allowed access to security group A. If the instance that we're targeting is in security group B and has access to security group A, we're going to want to actually revoke that access and ensure that security group B no longer has access to security group A, or we're going to want to inventory all the instances that are in the security group that has provisioned access to determine if there's an expansion of the scope of our investigation. We'll also want to look at the nature of the application on the EC2 instance. We want to understand what data sets it's been interacting with, what services that it interacts with. This is not just, again, AWS services, EC2 services. We want to know anything that's been interacting with on the internet. Did I cover that last bit too? Oh, again, continue to preserve all the data that you're gathering here. So let's talk about recovering. When we're trying to recover from this type of concern, we want to launch a new EC2 instance, but we don't want to place it back where that previous instance was just yet. We actually want to launch it from a known good Amazon machine image or a snapshot. We want that to be within a limited access security group at this point. We're not going to put it back into production just yet. And any new credentials that we're going to provision for this new EC2 instance, they should be roles. And why should we be using roles at this point?
So you're already in the scenario where you have reason to believe that credentials that were on the instance may no longer be trusted. And the time that you get to configure roles for EC2 is when you're launching a new instance. So this is the easiest point in time to launch the new instance with a role. And by running it under a role, you ensure that you get a separate auditable identity for that instance, separate credentials that get rotated frequently. And you may be in the situation now where the credentials that were on this instance were also on other instances, and now you have to go update them all over the place. Save yourself the hassle there. And why am I patching? Wasn't this fun? Don't I want to repeat the process?
No, we would rather not repeat this particular process. So let's make sure that we get it patched up to date. Check for any associated software public advisories as well. Just because you've done the patching process, just because you've run, whether it's yum update, apt-get upgrade, et cetera, that's not just enough. You need to go out and understand what application was this EC2 instance running. Can I find more information about that on the internet? Is there a public advisory right now associated with my particular application? Are there mitigations and workarounds that I should be applying at this point? Once you feel that you've gotten that to a pretty good warm fuzzy state, you're still going to want to run a vulnerability scanner against this EC2 instance. Make sure that we've got everything known good taken care of, and then we'll push it to production after we've gotten all of those best practices taken care of. Now, this is the work that you assign to the intern. This is going down and figuring out what actually happened. Go back to that suspect instance, and perhaps you can actually divide and conquer. So while you've got somebody that's working on the recovery operations, you might have somebody else working on the investigation. We don't necessarily assume that everybody has more than a two-man incident response team, but it might help to actually get a couple of divide and conquer things going. Go back to the suspect instance, take a snapshot of it, or you can log into it for the purposes of gathering data. You can use on-instance tools. You want to minimize that as much as possible. And generally, you want to do most of your analysis off-instance. Use off-instance analysis mechanisms to identify the most recent activity. Try and pinpoint what actually happened. So you're going to look into application logs. You'll look into directories for suspect behavior or data. And then you'll want to develop a timeline of activity and actions, also any IP addresses, and try and tie those IP addresses to known good actors or people that, that you don't know to understand who might have been interacting with this EC2 instance. It's important to understand that at this point, all of the data that you're gathering, again, you need to be preserving it. You'll want to go back to that and reference it as you're investigating.
And so what I want to do now is just shut down the instance, right?
No.
Kill it, get it off the internet?
Do not shut down the instance, because there's interesting things that we can do with that instance. Again, snapshotting it is one mechanism to gain access to at least the disk and then start performing forensics off instance. But you can actually interact with the instance and grab memory from it. So move the instance to a different restricted security group. You want to securely copy over a tool for actual extraction of the memory, such as the Linux memory extraction kernel module. You can dump that memory to disk and actually securely copy it off for off-instance analysis. Or you can actually, and that's one way to do it, but there's actually a cleaner way that requires you to do less interaction with the actual disk and certainly less commands that may interact with the data that you're gathering and keeps it more intact. And that's to network stream the actual memory across back to another instance. So edit the actual security group associated with that instance. Now it's isolated, but we're going to edit it, but we're going to allow forensic instance access. So a specific port from a specific IP or security group. And then for building, for grabbing memory and performing analysis on it later, you may have to perform some preparation of your actual tools. So creating an actual pre-built memory profile from a known good instance. So take the same Amazon machine image that instance was misbehaving from, launch an instance of that Amazon machine image, and now you're going to build all of your tools and your memory profiles from that clean instance and use that for your analysis. So here's a screenshot of, in this case, we've got our intern instance, which has been misbehaving, and we decide that we're going to go and look at that. Right now, it's got an open security group. If you look at that security group, it's allowing HTTP, HTTPS, so it looks like it's serving a web server. And we'll want to change the security group, isolating the instance. So we'll change it to an isolated security group in this case. There's no inbound, no outbound traffic to that security group. Now the target instance is still running, but now it's isolated. So you can see that its security group has changed from what was an open security group. It says it's isolated now, and we've looked at the rules. No inbound, no outbound. Let's go look at a forensics instance. It's actually an instance that's built from the same Amazon machine image, which is a known good public Amazon machine image, but we're actually going to build tools that are on it specifically for building a memory profile for dumping memory and performing analysis with it. Note the IP address of the forensics instance. We're going to need that to add to the isolated security group. So we'll go back to the isolated security group. Again, it has no inbound, no outbound rules. We'll add a specific rule that allows all traffic, but only from the IP address of our forensics instance. Then we'll want to make sure that we have connectivity to the target instance. So our forensics instance can still target or still reach our target instance or the intern instance. So we'll ping that guy. Looks like we're getting pretty good round trip times.
The instance, not the intern.
Copy over in insmod a Linux memory extraction kernel module. In this case, we'll want to build a memory profile specific to the actual Linux version. And so this is an example of actually copying over first our Linux memory extraction tool. Lime, if you're not familiar with it, is a very simple mechanism for basically loading a kernel module and dumping memory, whether it's to a file or actually over a network. So we insmod that. We've got it streaming memory on port 444. We're going to use a very complex but tried and trusted mechanism called netcat to pull our memory over to the forensics instance. So we'll netcat to intern, we'll stream the memory straight over to a local file on the forensics instance. Now again, there's some preparation that we'll have to make for the purposes of doing actual memory analysis. So we'll build a memory profile from the same Amazon machine image, the same Linux version. We're going to be building the memory profile because we need the same kernel structures and debug symbols for the purposes of actually doing memory analysis. And in this case, we're using volatility to actually do the memory analysis. And you can see here that we've built our profile and it's available to volatility for the purposes of doing analysis against a memory profile from another, in this case, Ubuntu Linux instance. Now that we have the memory that's over onto our forensics instance, we can use volatility to pull things out of that and find out what's going on. In this case, we're doing a dump of processes. There's a tree-based version of that allows you to see both parent and child processes. So if we look at that, we can actually see we've got SSH, we've got bash, we've got sudo, and we've got insmod. That actually is us having performed or logged into the actual instance and actually performing the insmod of our Linux kernel for extraction of memory. And that's expected. Everything else, though, we're going to want to pay attention to, right, and do a little bit more investigation. Now, if we have an intern who's decided that they're going to turn off their bash history, such as setting their hist file to 0 or setting hist file to dev null, and they think that they're going to get away with that, nope, we can actually get their bash history out of memory. So we'll use volatility, and we'll actually extract the bash history commands out of memory. And in this case, you can see there's somebody that's actually logged into that instance. They've run an upgrade of the actual operating system. They've rebooted it. And then you can see the last 3 commands, which are the commands that we ran, changing to the temp directory, doing an ls, and insmodding the Linux memory extraction kernel module. There are other things that we can do with memory analysis, such as looking at interfaces and looking at the IP addresses associated with those. Again, we're doing this all off of the instance. We're doing all of this investigation separate from interaction with the instance. The minimal interaction that we had was to actually grab the memory, extract it, get it back to a good place that we can actually inspect it. We can also check for rogue modules. So Volatility has an example of looking for Linux kernel modules that would be associated with a rootkit. And in this case, we don't have any, so maybe the intern just made some mistakes and there hasn't been anything else going on. Now we can also do disk analysis. So we created that snapshot from the instance. We did that by snapshotting the instance's volume. Now we can create a volume from that snapshot, and we can launch our forensics instance or a new instance for installing other types of forensics tools such as SleuthKit or Autopsy. There are publicly available community Amazon machine images that have forensics tools such as SIFT. And then we'll attach that volume, the snapshot of volume, we'll attach it to a forensics instance, and we'll DD all of the information from that to an image, because images are much more comfortable to work with a number of different tools.
So why don't you just install those tools right on the instance that's having the problem? Why go through all this work?
Again, we want to minimize our interaction with the instance that's been exhibiting suspect behavior. We want to do all of our analysis off instance, such that we're not manipulating anything and impacting our ability to investigate. So we'll create a hash of that image, we'll copy it to another volume for our purposes of working. We don't want to work off of the original image, right? We want to make sure that we're working off of a copy of that. Now, if we want to do that in a traditional environment, such as back home and on-premise or in the kitchen, I don't care. You can have S3 actually ship it to you on a disk. So use AWS import-export to get your data back to you in a box. We're pretty good at shipping things in a box, I hear. And if you want to, you can also download it. Download it would mean that you're going to spend time waiting for the bits to actually stream to wherever your location is. Or you can just analyze everything right there. Again, if you build an analysis instance within the AWS environment, you can attach the image to that analysis instance and start performing your disk analysis. Faster and cheaper. So let's talk about finding out that there's more instances running in a region that you didn't expect there to be. Maybe you're using the handy-dandy script that we had in the last talk that would tell you whenever you had greater than 0 charges in any of the regions other than US regions, et cetera. You've got that alert, you go and you find out that you have a bunch of EC2 instances. Again, you want to isolate any unwanted EC2 instances, get those to an isolated security group. If we're talking about resources such as more objects in a bucket than you expected, or maybe more people downloading an object that you didn't expect was public. If we're talking about objects tied to an open bucket, you'll want to ACL those appropriately and make sure that you check any of the bucket logs associated with that. You also want to review nearby CloudTrail events, particularly any relevant API calls, the credentials associated with this particular issue. So if we're looking at the CloudTrail events and we see AWS key IDs, we want to investigate all of those key IDs, understand who they belong to, and what the scope of those credentials are as well. And terminate any unwanted instances. You don't want to continue to rack up the bill. However, retain snapshots for analysis. Storage is cheap, and you can actually use those later on to understand what actually happened. Similarly, if you have unwanted objects that showed up in S3 bucket that was more open than you expected, you'll want to save those and review those later. Back them up. But don't forget to document all the metadata along the way. And what happens if the intern decides he's going to go on a delete tear in S3?
Well, you were using bucket versioning, right?
Absolutely.
OK, so then you've got all of your old objects, and you just use the S3 copy to copy the previous version back, and then you're good to go. Bucket logging, that's turned on. You can tell exactly what happened and review those logs. MFA delete is an option if you want to make it even harder for objects that you care deeply about to be erased. And another thing that you can look into is S3 lifecycle configuration can be used as the way that you manage your data retention so that none of the credentials that you have out there actually have the permissions to delete things.
And again, these are the mechanisms that we have for you to recover, basically go back in time and restore things. If you haven't turned these things on and you're not making use of these, and you'd like another option, I suggest buying a used DeLorean and installing a flux capacitor. So support. If you have an issue that you're dealing with and you need to engage us, you need some assistance, feel free to reach out to AWS support. We're your one-stop shop for any of your concerns, security related or otherwise. And if we can't immediately help you via our immediate support, we will have runbooks, we will have training that ensures that people are engaging subject matter experts internally to assist you. Also pay attention to our security best practices. We pointed out a bunch of those at the beginning of the talk. However, we have white papers that specifically talk about the tactics to each and every service, all the best practices that you should be doing for those, as well as monitoring, auditing, alerting, and incident response specific to those services. AWS security-related resources, check out the blog. We post interesting things there, and in one case, we've actually posted an entire lengthy blog post about how to deal with an identity access management credential exposure and to actually recover from that. And if you have any questions, you can always reach out to the AWS security team at aws-security.
Everyone got these URLs? Don't worry, the slides will be available later.
Absolutely. What are some other talks that they should have already gone to or that they should go to today?
The talks that you've probably already missed are up here. You can catch them on YouTube, given that we're getting towards the end of the day Thursday.
Also, external resources for incident response, particularly for those people that are still in the process of finding people, training people, building capabilities, building tools, and developing an incident response plan. You should check out the SANS reading room on incident response. A lot of great information there. And as people are building more information, they're targeting it towards cloud environments. So you're getting a lot of great information from more people in the public with regards to incident response. First, for training, you can go to conferences specific to incident response, and then CERT, of course, maintains a lot of documentation on incident management, particularly in developing an incident response plan. So what do you want everybody to understand today?
So if you do anything when you go back to your hotel room tonight, go in, turn CloudTrail on. It's really one slider in the console, enter a bucket name. You will thank yourself later. You want those logs. Similarly, you can't restore backups that you don't have. Either turn on versioning, take snapshots. It's incredibly useful to be able to go back in time, either to reconstruct a timeline of what went wrong or just to get back the data that was deleted accidentally.
We highly suggest that you take all of the recommendations within this particular talk, as well as the external resources. Again, make sure that you have the people, the tools, and the plan in place. You'll want that sooner rather than later.
And if you have another 20 minutes, stop using root credentials, please. Use reasonable least privilege. That way, you don't have to track down policy changes that may have been made.
And don't forget to practice. You don't actually have to have a real incident in order to actually experience what it takes to respond.
So I should practice uploading my credentials to a public repository?
Probably not.
Okay. I guess I could practice what I would do if they were there without putting them there.
That's right. Thanks a lot. Thanks for showing up. We really appreciate you showing up, and make sure that you give us feedback. We'll be outside in the Q&A area for questions. Thanks.
Yep.